Water also became important as a stimulus for economic change because of its role in generating power. Water wheels that can provide the motive force for certain mechanical processes reflect a very ancient technology. This is an example of the type of wheel that was used by the Romans to lift water into the aqueduct systems. Water wheels were also used to create mills that performed functions such as grinding grains, sawing wood, or processing wood pulp for paper. When the industrial age began to emerge in the late 18th and early 19th centuries, it was the water wheel that provided the power for factory machinery, such as we see in this English iron foundry. This affected the location and distribution of early industrial sites, as they needed access to rivers and streams to drive their machinery. By the late 1800s, factories were increasingly run by steam or electrical engines, but water remained an important source of power. The same period saw an explosion in the construction of dams and other projects designed to provide water for cities and agricultural irrigation. These projects were often also able to provide cheap, clean hydroelectric power. By 1920, for instance, over 25% of all electrical power in the United States was generated by water. With the growth of industrialization, water projects became ever more sophisticated and ambitious. Food production boomed as the amount of irrigated acreage increased. At the same time, rural populations fell and urban populations grew, compounding the traditional problems of water supply and sanitation that great cities had always faced. Requiring ever larger amounts of fresh water, governments worldwide spent lavishly on the creation of supply systems and sewers. By the early 20th century, it was increasingly common for urban dwellers in developed nations to enjoy running water in their homes and flush toilets connected to centralized sewers. The art of water engineering for the first time in centuries reached and then greatly exceeded the standards established by the ancient Romans. If we look at the modern age, this massive manipulation of natural water systems has created tremendous benefits for human society. Irrigated agriculture helps provide the food for growing populations. Hydroelectricity provides cheap, clean power for increasingly energy-hungry societies. And modern water systems have systematically reduced the spread of disease and improved the quality of people's lives. The United Nations today estimates that around 80% of the world's population has sufficient access to clean drinking water and proper sanitation systems. Yet, despite this progress, our relationship with the waterscape remains problematical. There are some severe global disparities. While the developed nations of North America and Europe boast high levels of access, other parts of the world suffer from serious shortfalls. In this map, we see the continuing shortages of pure drinking water, particularly in Africa. Here we see an even greater problem with proper sanitation systems, which are typically reliant upon good water supplies. This is a critical issue for much of Africa, Asia, and Latin America. While governments worldwide continue to try and address these disparities, certain key factors make it increasingly difficult. Currently, the world sustains a human population of some 6.6 billion people. It's estimated that this number will increase to 9 billion by 2042. This growth will strain the ability of existing systems to provide adequate supplies of fresh water. There will also be increasing competition between different users of water. The need to provide drinking water and sanitation for growing urban populations will inevitably clash with the pressure to increase irrigated farmland to feed the same population, and the need to divert water for industrial and power production purposes. There's also the simple fact that, despite the marvels of modern engineering, nature still has the upper hand in many ways. While over 70% of the world is covered with water, only about 3% of this is fresh water, suitable for drinking and agriculture, and an even smaller percentage is actually accessible for human use. While there are artificial ways to desalinate water, these remain extremely expensive and of limited use. The conversion of salt water to fresh water remains, by and large, a monopoly of nature, which accomplishes this task through the ancient cycle of evaporation and precipitation. Thus, while we can control some aspects of the waterscape, other components remain untamed. In some cases, this is manifested by nature providing too much water. In 1931, for instance, wild flooding along the Yangtze River killed an estimated 1 million people, with millions more dying from starvation caused by the destruction of farmlands. Even in the United States, which has created one of the most sophisticated water control systems in the world, flooding remains a serious problem. In 1993, for instance, the rapid rise of the Mississippi and Missouri rivers inundated 30,000 square miles and caused some $15 billion worth of damage. In 2005, the breach of the levees in New Orleans left virtually the entire city underwater, killing over 1,000 people in the process. Nature's continued dominance can be seen as well on the flip side of this, the absence of water. At the same time flooding was devastating the Chinese heartland, North America witnessed a catastrophic drought on the Great Plains. With little rainfall, the fertile topsoil of the region was swiftly eroded by winds, creating massive dust storms. In part, this disaster reflected an ill-advised effort to farm in a region that didn't have the natural supplies of water to support this activity. The end result was the destruction of huge areas of farmland and millions of people being forced to abandon their homes. Today, drought is a growing problem, particularly on the continent of Africa. Some of the limitations we face are imposed by nature, but poor human management of water resources is also a critical factor. This is hardly a new phenomenon. For millennia, human societies have often negatively impacted waterscapes because of improper disposal of sewage and other wastes, poor irrigation techniques, and deforestation. This has had broad-ranging significance in terms of damaging natural ecosystems and has also often rebounded to harm human societies themselves in terms of inadvertently spreading disease, promoting potentially dangerous flooding, and causing a decline in water supplies and soil fertility. In the modern industrial age, these impacts have grown ever larger. Pollution from industry and mining has long been a key source of environmental degradation, and while already developed societies have certainly begun to pay more attention to these issues, developing nations, faced with a choice between slower economic growth and protecting the environment, have often chosen the former course. Population growth and the change towards a more urbanized global society has also raised the stakes. Pressures to produce enough food to support this population has often led to unsustainable agricultural practices, such as over-irrigation, the extensive use of pesticides and chemical fertilizers that ultimately end up contaminating freshwater supplies, and deforestation to provide ever more farmland. Urban industrial society itself reshapes the waterscape in a number of ways. The need to provide water and power, for instance, continues to encourage governments to pursue water projects, such as dams, that have negative effects upon the environment. The very fact that cities cover the land with buildings and concrete roads reduces the ability of the land to naturally absorb water into underground aquifers. Scientists also believe that global warming, as a result of human activity, has contributed to troubling changes in the climate, including the decrease of rainfall in some parts of the world. These factors have all impacted obvious sources of fresh water, such as lakes, rivers, and streams. But perhaps even more devastating has been the impact upon groundwater supplies. As the demands for water have grown around the world, many societies have increasingly turned to reliance upon underground aquifers to meet the shortfall. In the United States, for instance, it's estimated that half of all drinking water and almost 40% of irrigation water is drawn from underground aquifers. Yet, this is a highly fragile resource. There is an alarming trend towards overpumping, that is, taking out more water than can be naturally replenished through absorption into the soil. And pollution, which is introduced into groundwater, tends to remain for very long periods of time, unlike river systems, which are constantly flushed by rainfall and snowmelt. What can we learn from this brief examination of water's impact upon the development of human societies, past and present? Well, clearly water has been and will continue to be a critical natural resource. Without an abundant supply of fresh water, it would simply be impossible to sustain the population levels and quality of life that many of us enjoy. By looking at history, we can see that over time, human beings have been tremendously creative in developing water systems. Yet, for all of our ingenuity, history also teaches us that our relationship with the planet's waterscape is a partnership with nature, a partnership that still can prove to be perilously fragile.